Hello class, this is a video tutorial on factoring examples. You can pause the video and give these a go yourself, just going from what you've seen in the previous video. So we have 3 examples, 1, 2, and the third one is here. So at any time you can pause the video and give this a go yourself. So to begin with, we first need to figure out what we're dividing by. Remember, we're dividing by x minus some number a. And the first number we should always look for is some factor of 6. You can quickly find this. Well, you can figure out very quickly just by substituting f of one of the numbers you want to test for a. For the sake of the video, I already know that one of them is going to be 1. So if you just tried 1 and you substitute into your calculator, 1 cubed minus 2 times 1 minus 5 times 1 plus 6, you should definitely be getting 0. So because you have that condition, we know that this first divisor is going to be 1, and so we can now do our synthetic long division. 1, negative 2, negative 5, and 6. Ignoring the first, multiplying, adding, negative 1, multiplying, be negative 1, adding, multiplying, and then adding. So our first division is f of x can now be written as x minus 1, the divisor, times the quotient that we have from our division. And always remember, since this is cubed, this is now going to start off at x squared. So 1x squared minus 1x minus 6. From here, you could try and do a test again for values or factors of 6. But thankfully, this is just a quadratic, which is a lot easier to factor. So I can already think of 2 numbers here. It's going to be positive 2 and x negative 3. So f of x is fully factored as these 3 values here. It's that simple. So you can try it again for this one here. Go ahead, pause, and give it a go yourself. Now remember, the first value we need to divide by, a, if we substitute it into our function value, so our function g of a, it should come out as 0. You can start testing any number that you can think of factors of 18. But I already know if we substitute negative 1, it should come out as a 0. So let's go straight into negative 1. Now remember, this is because I know what the factor is. Normally, you have to test yourself these different values here. So if it's negative 1, that'll be minus 1 like this, which will give us plus 1. So taking our coefficients 1, 5, 1, negative 21, negative 18. Ignoring the first, multiplying, adding, 4, multiplying, adding, that will give me negative 3, multiplying, adding these 2, which will give me what's that, negative 18, multiplying, and then adding. So g of x, the first factor is x plus 1, and from our long division, it started at 4. Since we've divided it, this will be now x cubed plus 4x squared minus 3x minus 18. And then from here, we test yet again. We're going to divide only this expression here, and we treat that as a new function. Let's think of that as q of x, and the numbers we need to test are factors of negative 18. Once again, for the sake of this video, I know that the value of q of negative 3 will definitely give me 0. That means if I substitute negative 3 into these values, it will definitely be a 0 for this. So I know that my next divisor is going to be x plus 3. So it's grabbing another box here. We're going to be doing another long division with the numbers negative 3 and the coefficients of just this quotient. So 1, 4, negative 3, negative 18. Ignoring the first, multiplying, adding, that will give me 1, multiplying, that will give me negative 3, adding, will be negative 6, multiplying these two will give me positive 18, and adding these two will give me 0. So g of x can now be written as x plus 1, x plus 3, and this quotient here. Now remember, this quotient was taken from the division of this divided by our dividend. And since this started on 3, this is now going to be x squared. So x squared plus x minus 6. This is now a quadratic, which we can factor much more simply without doing this long division. So x plus 1, x plus 3. Let's think of two numbers that multiply to negative 6, but add to positive 1. I can think of positive 3 and negative 2. And that there is fully factored. If we want to make it even neater, I can see that these two are a repeated root, or a double root, which we can write as x plus 3 all squared, x plus 1, x minus 2. And that there is fully factored of g of x. Now that you've seen that, you can try the last one yourself. And here we go. Oh, actually, as you've seen, this is to the power of 4. Now that you've seen it to the power of 4, how we just repeat it once again, it seems as if that we can repeat it no matter what degree the polynomial is, which is definitely the case. So let's go straight into it. We want factors of 24. So we're dividing by x minus a. Just for the sake of the video, I already know what the first one I'm going to test. I'm going to test negative 1. You can try substitute that in, h of negative 1, type it into your calculator. You should definitely be getting 0. So doing our long division here, negative 1, taking the coefficients 1, negative 2, 13, oops, not negative, 14, and 24. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, which will give me 10, 24, multiplying, adding, and there we go. So our first factor of h of x is going to be x plus 1 times, this is x to the power of 4, so this is going to be x cubed. So 1x cubed minus 3x squared, 10x plus 24. Once again, we're going to test different factors of 24. You can go ahead and keep testing, trial and erroring, but I can definitely show you that the next one you should be testing is positive 2. So if you take this to be, let's say, q of x, if you substitute in 2, that should definitely be giving you 0. You can try that yourself. So let's grab another one of these division boxes. And let's do another long division with 2 as our dividend. 2. Taking the coefficients of this polynomial. So 1, -3, -10, and 24. Ignoring the first, multiplying, adding, -1, -2, -12, multiplying these two, that'll give us -24, and then adding. So h of x can be written as x plus 1, x minus 2, and once again, because this is x cubed, this begins on x squared. And this is the last step. Because it's a quadratic, we can very easily figure out the two factors here. I can think of +3 and -12. Oh, sorry, -4. And that there is h of x fully factored. And just showing you the rest. There we have it. So I hope that gave you an insight into factoring high degree polynomials using long division. Hope to see you in the next video. Best of luck.